All right, so here is 20 through 33 of the review sheet for Chapter 4. Number 20 says write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So we are going to use 1. That's our first zero. And that gives us a factor of x minus 1 with the opposite sign. And then when we have 3 plus 3i, this is one of the zeros. That means 3 minus 3i is also one of the zeros. So that's x minus, let's always subtract, 3 minus 3i, and x minus 3 plus 3i. The imaginary solutions always come in pairs. So we're going to multiply those together. We have x minus 3 plus 3i when I distribute the negative, x minus 3 minus 3i, and we're going to multiply that together. You know I like the vertical multiplication because this is how you multiplied when you were younger. I do the 3i times everything, so that's what I'm going to do first. Negative 3i times positive 3i is negative 9i squared. And negative 3i times negative 3 is plus 9i. And negative 3i times x is negative 3xi. Then I'm going to multiply the negative 3. Negative 3 times 3i is negative 9i. Negative 3 times negative 3 is plus 9. I'm putting the plus 9 under the I squared because the I squared is going to turn that into a real number. That way they're lined up. Negative 3 times x is negative 3x. And then x times 3i is positive 3xi. And x times negative 3 is negative 3x. X times x, x squared. So in the end here, the 9i's cancel and the xi's cancel. So 3xi's. I squared equals negative 1. So that's negative 9 times negative 1, which is positive 9. So positive 9 plus positive 9 is 18. And then I have negative 6x, and then I have x squared. So we get x squared minus 6x plus 18. Now we have to multiply by the x minus 1 factor. So we get negative 18. I get positive 6x, and I get negative x squared. Always multiply together your imaginary or your radical first, because then it turns out with no radical or imaginary coefficients. And then x times 18, 18x, x times negative 6x, negative 6x squared, and then x times x squared is x cubed, for a final answer of x cubed minus 7x squared plus 24x minus 18. And that is your final answer. Okay, and number 21 says graph the function. So I'm going to move this stuff over like that. We have a double root at positive 1, a double root at positive 1 and negative 1. I have an x squared and an x squared. That makes it x to the 4th. So it's even. And then the coefficient in front, if I look at this coefficient is, there isn't 1, so that's a positive 1, so it's even and positive. So it's up and up. So when I look at my graph, I have negative 1 and positive 1. It starts up. It's going to bounce because it's a double root. It's going to bounce, and that's what my graph looks like. And if I was asked to write the end behavior, just as a review, because we've only done this a little bit, f of x over here goes to positive infinity as x goes to positive infinity. And f of x goes to positive infinity over here as x goes to negative infinity. That's how you would write the formal notation. Now the next two on the slide are also graph the function. X minus 6 squared x minus 3 and x minus 1. So we have zeros of 6, 3, and 1, and this is a double root because of the squared. So that's x squared times x, that's 4, so x to the 4th is even, and it's positive in front, so even positive again. So we have 1, 3, 4, 5, and 6. So the graph's going to start here. It's going to pass through the 1, turn around and go through the 3, turn around and bounce off the 6, because the double roots bounce. And again, the end behavior notation would be the same as the last one. Now, 3x cubed minus 6x squared, let's factor that so we can get the zeros. Let's factor out a 3x squared, and then we get x minus 2. So I have zeros of 0. Whenever I have that x squared in front, the 0 is 0, and it's a double root. And then I have a 0 of positive 2. And the 3 is positive. It started as x cubed, so it's positive and odd. So it's going to start negative and end positive. And I have a 0 and a 2. So I'm going to bounce off the double root, the 0, turn around and go through the single root. So it looks like that. Number 24 says estimate the zeros, local maximums, and minimums of the polynomial. So the zeros are pretty clear. Zeros are where they cross the x-axis, right? So this is positive 3, negative 2, and negative 5. And then my local maximums and minimums, here are my minimums. Okay, so the local minimums are at negative 12, and this one here is at negative 3. You just list a y value, and the local max is here at 0. Okay, let's look at the next one. Same thing. The zeros are at negative 4, negative 2, 0, and 1. And then my local mins and maxes are maximum, maximum. So I have a local max of about 7. And that looks like it's about 1.5. And then I have a min here of negative 3. And then number 26 says list all the possible zeros of the function. So the possible zeros is making our p and q list. So our p's are the factors of negative 24. So that's 1, 2, 3, 4, 6, 8, 12, and 24. And then our q's are 1 and 2. So our p over q list is plus or minus 1 over 1, plus or minus 2, plus or minus 3. These are all the plus or minus over 1. And then the 1 over 2. 2 over 2 is 1, so I don't need to write that one. 3 over 2. 4, 6, 8, 12, and 24 divided by 2 are all numbers that are listed in the original list, so I don't need to add those. And so my final list is this set. The next set of problems show that the binomial is a factor and then factor completely. So we're going to do synthetic substitution. If it's x minus 3, I'm going to put in a positive 3, and my coefficients are 1, 5, 0 for the missing, not 0 there, 24, and then 0. Negative 24, and then 0, because you don't have a constant. So we get 1, 3, 8, 24, 0, 0, 0. So that worked. What do I have left? I have x squared plus 8x plus 0. I don't need to write plus 0. And I can factor out an x. X times x plus 8. And then what factor did I start with? I started with the x minus 3, so I want to include that in my answer. And so number 28, x plus 7, so I'm going to put in a negative 7. 1, negative 4, negative 49, and 196. So 1, negative 7, negative 11, negative 77, positive 77, and 77 minus 49, so that's 28, positive 28, and 28 times 7, I'm guessing, is 196, that's 56, 14, 19, 190, negative 196 is a 0. So that's how we show that it's a factor, and then you factor what's left, minus 11x plus 28, and this is x minus 4, x minus 7, and what did I start with? An x plus 7, so include that one in my final answer. And then lastly, number 29, let's move some of this stuff up. It's x minus 2, so I'm going to do plus 2, and it's 1, negative 2, 0, because it's missing an x squared, negative 27, and 54. So 1 times 2 is 2, negative 2 plus 2 is 0, 0 times 2 is 0, 0, 0 times 2 is 0, negative 27, negative 54, and 0. So that shows that it's a factor. I have x cubed minus 27, which is a difference of cubes. And that's our pattern, x minus 3, a minus b, a squared plus ab plus b squared. So my a is x and my b is 3, so x squared plus 3x plus 9. And then what factor did I start with? I started with an x minus 2. You can put it on the front or at the bottom end. That's my answer there. Find the zeros of the function, then sketch a graph of the function. These ones we can find the zeros by factoring. So looking at number 30, we're going to make it equal to 0 and factor out a negative 4x. And then I get a positive x squared plus 8x. And 60 divided by 4 is 15 plus 15. Negative 4x, and that's x plus 3 and x plus 5. So my zeros are 0 for the 4x, negative 3, and negative 5. It's only 0 when the coefficient, when there's an x in front of the parentheses. Now this started negative and odd, so I'm going to draw it. 0, negative 3, negative 5. Negative odd starts up high and ends down low. So I'm going to start up high, go through each of my zeros, and end negative. And that's my sketch. 31 is x to the 4th minus 18x squared plus 81, which is a quadratic form. That's x squared minus 9. And x squared minus 9, because negative 9 and negative 9 multiply to 81 and add to negative 18. That factors to x plus 3, x minus 3, and x plus 3, x minus 3. Neither of these are positive. These are both difference of squares. So we have a double root of 3 and negative 3. And it's positive and even. So positive, even is up and up. So I'm going to start up and bounce off my roots. So bounce off, bounce off. And if we want to be real accurate, this is about 81, how high it goes. And then up. Negative, let's do a different color so it stands out. Negative x cubed plus x squared plus 25 x plus minus 25. Factor by grouping, so I'm going to take a negative x squared out, and I get x minus 1, and I'm going to take a negative, I'm going to take a positive 25 out, and I get x minus 1. Then I'm going to take out my x minus 1, and I have negative x squared plus 25. I can actually factor out that negative, so I'm going to make it negative x minus 1 and x squared minus 25. I took the negative out of this one and put it in front, because it would be weird if it was between. It would look like subtraction, and that's x plus 5, x minus 5. And my zeros are 1, 5, and negative 5. It's odd, and it's negative. So when I graph it, it's going to start in the positives and end negative. I have 1, 2, 3, 4, 5. These are my zeros. 1, 2, 3, 4, 5. It goes through all of them. None of them are double roots. So it starts up here, goes through the negative 1, goes through, or positive 1, and goes through the positive 5. And this, wherever it passes here, is negative 25, because that's my constant here. Okay, last two problems, looking at the end behavior of the graph of the function. So it's really important on these on the test that you look for the highest exponent. They may not be in order for you. So as I go through number 33, this is in order. So my highest exponent is the 4. So that means we are even, which means they're going to be the same. And we are negative, which means they both are down, right? Down, down. So looking at this, pay very close attention to what is listed first. This one lists the negative infinity first. So h of x goes to negative infinity as x goes to negative infinity. That's correct because it's down on this side. And h of x goes to negative infinity as x goes to positive infinity. That is also true, negative infinity on the positive infinity side. Looking at B says negative infinity, but then it says positive, so that would have it up here on this side. And then C is positive infinity and negative infinity, which is not true because this is negative, and then positive at negative. So you want to really pay close attention. The answer here is A, to what you're reading. And again, in number 34, you see it's written here with the negative x at infinity first, and my polynomial is not in order, so pay really close attention because my highest term is in the middle here. It's a positive 4x to the 4th, so it's positive even, which means they're both up. So we're going to look for positive infinity at negative infinity, which is not true, negative and negative, so it's not A and it's not B. So C is positive infinity at negative infinity, and negative infinity at positive infinity, which would be like that, so that's not correct. So it looks like D is probably at positive infinity at negative infinity, and positive infinity at positive infinity, so C of x is positive in both terms, and that is letter D, your answer. And that is all.